Hello there, Mr. Sutton here, bringing you the Algebra 2 1.3.2 homework solutions on modeling with linear functions. In this one specifically, we are dealing with finding lines of best fit. For this first problem, we're trying to determine if the data here show a linear relationship and then come up with the line of best fit, plug in 15, and explain the meaning and the context of this situation here. So we have this table with minutes walking and calories burned. All right, so to do any of this, I'm going to go to Desmos and enter this in a table on Desmos. So here I am on Desmos, and I'm going to hit this little plus to get me my table, and then just enter these in here. So we've got 1, 6, 11, 13, and 16 for the x values. And then coming back up, let me do the y values. So 6, 27, 50, 56, and 70. And now I'm going to move this over so I can see it. And let me do the little magnifying glass to get a picture of all these. Yeah, it looks pretty linear to me. Let me now hit my regression line button here. And definitely looks very linear when I do that. So let's see here. My equation is this y equals, this is my line of best fit down here, this y equals 4.259 and some change x plus 1.763 and some more change. So let me just redraw that for you. Definitely linear. There's my line of best fit approximated. Now they want me to estimate y when I have x equals 15. So we're just going to plug 15 into this. And to do that quickly on Desmos, I'm going to click this little button here that it exports that equation down to the next entry level. I'm going to change this y to an f of x just to make it easier to plug things into. And then I'll just come down one more entry here and do f of 15. So that's coming out to about 65.65. So there we go. And let's see here, interpreting this in the context of the situation. So what does this mean? I plug in 15, I get about 66 back. Well, that means after 15 minutes of walking, that's our x value, we've burned about 66 calories. Good to know. For this problem, I'm trying to figure out if this data here gives me a linear relationship. If so, I want the line of best fit. I want to know the y value when x equals 15, and I want to know what that all means. So to Desmos we go. Let's see if we can get a linear relationship when we graph this out. So let me hit my plus up here on Desmos to get a table. So we've got x values of 3, 7, 9, 17, and 20. And I'll just come up here and put the y values in. We had 86, 61, 50, 26, and 0. Is that linear? Let me press the little magnifying glass to get a zoom fit window here. And I'll just move this over so I can see it all. Yeah, that looks basically linear. Let me press the linear regression button now and see what we come up with. So our equation for our linear regression down here is going to be y equals negative 4.585 if I round it, x, plus 95.948. So definitely linear. There's our equation. And to plug in 15, I'm going to go back to Desmos, and I'm going to export that equation down here. So now we have f of x equals all that stuff. I'm just going to use that. It's a little easier to plug things into. So f of 15 is about 27.18. Now what does that actually mean? Well, when I plug in the x value 15, that's 15 hours that I'm plugging in here. And the y value is battery life. So after 15 hours, I have a battery life remaining of roughly 27%. Better charge that. On this problem, we're going to be using some technology, namely Desmos, to find an equation of the line of best fit for this data set. And then we're going to figure out and interpret the correlation coefficient. So first we have to take all these points and plot them on Desmos using the table. So let's go to Desmos for that. So here's Desmos. And let's do the plus here to start entering a table in there. So let me do the x values. Well, let me do the points. We'll do them point by point so I don't miss anything. So we've got 1, 1. And next up we have, let's see here, that's 2, 3, and then 3, 2. This is 4, 3, and then this up here is the point 4, 5. Over here we've got 6, 3, and then finally this is going to be 6, 4. And let me just do my little magnifying glass to get a nice window on those and hit my regression line. So the equation that they're giving us is y equals 0.42x plus 1.44. That's my linear regression. So we'll put that in there. So there's what I just drew, and there it is. Now they also wanted the R value, that's the correlation coefficient, and an interpretation of it. So the R value from Desmos, looking right here, is going to be about 0.61. Now remember, the R value ranges from -1 to +1, and the closer you are to one of those extremes, the stronger the correlation. This isn't a super strong correlation. I mean, it's not like 0.9 or anything like that, but it's not super weak either, so I would call this a moderate positive correlation. On this problem, we're trying to figure out the line of best fit and the correlation coefficient. So just like we've done on the previous problems, let's go to Desmos and enter these points into a table. So for my table, let me do plus and then table, and then go through my points. So up here we've got 1, 5, and then this is going to be 2, 4, and right below it 2, 3. Over here we've got 3, 3, and this is 3, 2. And then down here 4, 1, and this will be 5, 1. And that looks about what I've got in the graph there. So let me hit the magnifying glass, get a slightly better view, and then regression line up here. And then scroll down to see my equation. So the equation is negative 1.039 if I round off, x plus 5.684. And then we have an R value of negative 0.93. So just putting that all here, there was my graph, there was my equation, and my R value. Now as R values go, this is very close to -1. So this is going to then be a strong negative correlation. On this next problem, we're going to use Desmos to figure out the line of best fit for this thing and then the correlation coefficient. So let's go to Desmos. On Desmos, I'm going to hit my plus and get a table, and I'm going to enter all these points into this table one at a time. So right here we've got the point 1, 1. Next up is the point 2, 1. And then we've got this next one is 3, 2, followed by 4, 2, and also 4, 3. We had 2 on the same vertical line there. Next, this is 5, 3. And finally, we have, let's see, this will be 6, 4. Getting my magnifying glass to get all those in one place. That looks like what I have over on the graph here. Let me do my regression line button. And looking at my equation down below, we've got y equals 0.613 if I round off with an x, and 0.097. Also, we have an R value of 0.95 if we round that off. So graph, equation, and I rounded my equation to 2 decimals, so that's why you're not seeing the 0.9 there. It was just a 10 if you rounded up. And then finally, that R value was 0.95. Now, in terms of interpreting this R value, this is pretty close to +1, so this is going to be a strong positive correlation. On this last problem, we're going to be finding the line of best fit for these points and also the correlation coefficient. So to Desmos we go. In Desmos, I'm going to hit plus and pull up a table and then enter these points one at a time. So this first point is 1, 4. Next point over is 2, 3. After that, we've got let's see, this is 3, let's just go from bottom to top, 3, 2, and 3, 4. Next up, this is 4, 2, and 4 3s right there. And then finally we have 5, 2. All right, so let's hit our magnifying glass to get a zoom fit on those. Didn't really do much, but I like to do it. And then we have that regression line that we're adding. And it doesn't look like a great correlation line-wise, but let's look at our equation and our R value. So my equation, I've got negative 0.045x if I round off, and plus 4.26. And then for the R, we have negative 0.67. So graph, there's what I just got for my Y value, my Y line of best fit, and then the R value. Now as R values go, this isn't super close to -1, but it's not all that close to 0 either. So it's not really strong or weak. I would call this kind of somewhere in the middle, like a moderate negative correlation.